Apps that talk like magic. Welcome to the channel. I would appreciate it if you subscribe. I produce videos daily covering various topics with a focus on cloud solutions. Also, hit the notification bell to get notified of new videos. Imagine if your favorite food delivery app could instantly talk to the restaurant's kitchen, the driver's GPS, and your bank account, all at the same time, in real time, without any delays or mistakes. That's what gRPC does. It's like giving apps superpowers to communicate with each other instantly and perfectly, which makes your daily digital life faster and smoother. Think about when you order an Uber. The app needs to talk to the driver's app, the payment system, the GPS service, and the rating system. gRPC makes all these conversations happen lightning fast. Today, we'll explore how this magic communication system works and why it makes the apps you use every day faster, more reliable, and more responsive to your needs. The food delivery problem. Let me tell you about Sarah's pizza ordering experience. She opens her favorite food app, picks a delicious pepperoni pizza, and hits order. But here's what happens behind the scenes that she doesn't see. The app needs to check if the restaurant is open, verify her payment method, calculate delivery time, find an available driver, update inventory, send kitchen instructions, and track the order in real time. With old technology, this was like playing telephone with 6 different people, slow, error-prone, and frustrating. Sometimes Sarah would get charged but the restaurant wouldn't get the order. Sometimes the driver would show up but the food wasn't ready. This is exactly the kind of problem that happens when different computer systems can't communicate efficiently. Each delay, each miscommunication, each error directly impacts real people like Sarah trying to get dinner. The solution? We need a way for all these different systems to talk to each other instantly and reliably. Like they're all sitting at the same table having a conversation. What is gRPC really? Think of gRPC as a universal translator for computer programs. You know how Google Translate can take English and instantly convert it to Spanish? gRPC does something similar, but for apps. It stands for Google Remote Procedure Call, but don't let the technical name scare you. Remote Procedure Call just means asking another computer to do something for you, as if it was right next to you. Imagine you're at a restaurant. Instead of walking to the kitchen to tell the chef your order, you tell the waiter, who instantly and perfectly communicates your request to the kitchen. That's what gRPC does for apps. The magic is that it makes apps on different computers, written in different programming languages, able to work together seamlessly. A Python app can talk to a Java app like they're best friends speaking the same language. This matters because most modern services, like Netflix, Uber, or Instagram, aren't just one app. They're dozens of small apps working together, and gRPC is what makes that teamwork possible. The magic communication system. Let me show you how gRPC creates this magic communication. It is like having a super efficient postal service, but instead of letters taking days, messages arrive in milliseconds. First, there is the universal language protocol buffers. Think of it like creating a special shorthand that all apps understand. Instead of writing "Please send me information about user John Smith," it becomes a tiny, compressed code that means the same thing. Then there is the superhighway, HTTP/2. Regular web communication is like a single-lane road where cars' messages have to wait in line. HTTP/2 is like a 16-lane highway where hundreds of messages can travel simultaneously. Finally, there is autopilot, code generation. Instead of programmers manually writing thousands of lines of communication code, gRPC automatically creates perfect communication code in any programming language. The result? Apps can send thousands of messages per second with perfect accuracy, while using minimal internet bandwidth and battery power. Pizza delivery. Before and after. Let's see how gRPC transforms Sarah's pizza ordering experience. This comparison will show you exactly why this technology matters for everyday apps. In the old way, each step was like making separate phone calls. The app calls the restaurant, then calls the payment system, then calls the driver system, and so on. Each step could fail or be slow. With gRPC, it's like having a conference call where everyone talks at once, instantly, and in perfect harmony. The moment Sarah hits order, all systems start working together simultaneously. The restaurant gets the order, the payment processes, a driver gets notified, the kitchen starts cooking, and Sarah gets real-time updates, all within seconds, not minutes. This isn't just faster, it's more reliable. If something goes wrong, all systems know immediately and can fix problems before Sarah even notices. That's why modern apps feel so smooth and responsive. The best part? Sarah gets her hot pizza faster, the restaurant serves more customers efficiently, and drivers have better routes. Everyone wins. Types of conversations. Just like people have different types of conversations, apps need different ways to communicate. gRPC supports 4 types, and understanding them helps explain why modern apps work so well. Simple request response is like asking, "What's the weather?" and getting, "It's sunny, 75 degrees Fahrenheit." Perfect for things like logging in, checking your account balance, or looking up a contact. Streaming from server is like subscribing to a live news feed. The app asks, "Tell me about my delivery," and gets continuous updates. Order received. Cooking, out for delivery, 5 minutes away. Perfect for live tracking. Streaming to server is like uploading a bunch of photos to social media. You send multiple photos, and when all are uploaded, you get one confirmation. Great for bulk operations. Two-way streaming is like a video call. Both sides can talk and listen simultaneously. Perfect for chat apps, collaborative documents, or online gaming where real-time interaction is crucial. Each type is optimized for different scenarios, which is why your apps can handle everything from simple searches to complex real-time interaction. Real-world benefits you experience. Here's how gRPC directly improves your daily digital experience, even though you never see it working behind the scenes. Faster app responses. When you open Instagram and see photos load instantly, or when you tap, call, on WhatsApp and connect immediately, gRPC is often making that speed possible by enabling efficient communication between services. Better battery life. Because gRPC sends much smaller, more efficient messages, your phone doesn't have to work as hard to communicate with servers. This means your battery lasts longer throughout the day. More reliable connections. Ever notice how modern apps work better even when your internet is spotty? gRPC includes built-in error handling and retry mechanisms that keep things working smoothly. Smoother real-time features. Live location sharing in Google Maps, real-time collaboration in Google Docs, or instant messaging all benefit from gRPC's streaming capabilities. The bottom line: gRPC is working behind the scenes in many of your favorite apps to make them faster, more reliable, and more responsive to your needs. Gaming. A perfect example. Online gaming showcases gRPC's power perfectly. Imagine you're playing an online multiplayer game with friends around the world. Every move you make needs to be instantly shared with all other players. Without gRPC, this would be like shouting across a crowded room. It would be slow, unreliable, and frustrating. Players would see laggy movements. Actions would be delayed, and the game would feel broken. With gRPC, it's like everyone wearing high-tech headsets with crystal clear, instant communication. When you jump, everyone sees it immediately. When someone shoots, the action registers instantly for all players. The streaming capabilities mean the game can send continuous updates about player positions, health, ammunition, and game state. The efficient compression means this happens without using excessive internet bandwidth. This is why modern online games feel so smooth and responsive compared to games from just a few years ago. The underlying communication technology has dramatically improved. And it's not just games. This same technology powers live sports streaming, video calls, collaborative editing, and any application where real-time interaction matters. The business impact. While we have focused on user benefits, gRPC also creates significant advantages for the companies building these apps, which ultimately benefits us as users. Two companies can build new features faster because gRPC handles all the complex communication automatically instead of spending months building connection code. Developers can focus on creating cool new features for users. Apps are more reliable because gRPC includes built-in error handling, monitoring, and debugging tools. This means fewer crashes, fewer something went wrong messages, and more consistent experiences. Services can handle more users with the same hardware because gRPC is so efficient. This keeps costs down for companies, which helps keep services affordable for users. Global expansion becomes easier because gRPC works the same way everywhere. When your favorite app launches in a new country, the underlying technology does not need to change. The result is a virtuous cycle. Companies can innovate faster and more reliably, which creates better user experiences, which allows for more growth and innovation. When not to use gRPC. Like any technology, gRPC isn't perfect for every situation. Understanding its limitations helps explain why we still have different types of apps and services. Simple websites that just display information, like a restaurant's menu or a company's about page, don't need gRPC's power. It would be like using a Formula One race car to drive to the grocery store, unnecessary and overcomplicated. Public APIs that need to work with any browser or simple tools stick with REST because it's more universally accessible. Think of REST as the common language that every web browser understands without special setup. Small projects or prototypes might avoid gRPC because it requires more initial setup. Sometimes you just need to build something quick and simple, and gRPC's power comes with complexity. However, for any app that needs to coordinate multiple services, handle real-time interactions, or serve millions of users efficiently, gRPC often becomes essential. The good news is that as a user, you don't need to worry about these technical decisions. The apps just work better when the right technology is chosen for the right job. The future is connected. As our world becomes more connected, technologies like gRPC become increasingly important for creating seamless digital experiences. Smart homes where your thermostat, security system, and lights all work together instantly. Electric cars that coordinate with charging stations, traffic systems, and your calendar. Health apps that securely share data between your doctor, fitness tracker, and insurance company. All of these scenarios require different systems to communicate efficiently and reliably, exactly what gRPC enables. The Internet of Things (IoT) is creating a world where everything is connected, from your refrigerator to your city's traffic lights. gRPC's efficiency makes it possible for these devices to communicate without overwhelming internet infrastructure. Even more exciting, technologies like AI and machine learning rely heavily on different services working together to process data, learn patterns, and provide intelligent responses. gRPC is often the invisible backbone making these smart features possible. So while you might never write gRPC code yourself, understanding it helps you appreciate the incredible engineering that makes modern digital life possible. Build your own smart home assistant. Want to see gRPC in action? Let's build a simple smart home system that you could actually use. This example shows how easy it is to create connected applications. Imagine you want to control your home devices from your phone. With gRPC, you can create a system where your phone app talks to a home server, which then controls lights, temperature, and security. The beauty of this example is that it mirrors real smart home systems like Google Nest or Amazon Alexa. The communication patterns are identical, just simplified for learning. You'll see how the protocol buffer definition creates a contract between your phone app and home server. Both sides know exactly what commands are available and what responses to expect. The Python code shows how incredibly simple gRPC makes this. What would normally require complex networking code becomes just a few lines that look like normal function calls. This same pattern scales up to control hundreds of devices, handle multiple users, and add features like scheduling, automation, and remote access, just like commercial smart home systems. Real-time chat application. Here is another practical example. Building a real-time chat system like WhatsApp or Discord. This shows gRPC's streaming power in action. The cool thing about this chat example is that it demonstrates bidirectional streaming. Both users can send and receive messages simultaneously, creating a natural conversation flow. Notice how simple the code is compared to what you'd need with traditional web technologies. No complex WebSocket management, no manual message queuing, and no connection handling headaches. This pattern is exactly what powers modern messaging apps. WhatsApp, Discord, and Slack. They all use similar streaming communication patterns to deliver messages instantly. You could extend this basic example to add features like group chats, file sharing, emoji reactions, read receipts, and more. Each feature would just be additional methods in your service definition. The server can handle thousands of simultaneous chat sessions efficiently because gRPC's HTTP/2 multiplexing allows many conversations to share the same network connection. Most importantly, this code would work identically whether your friends are across the room or across the world. gRPC abstracts away all the networking complexity. Key takeaways. Let's wrap up with the most important points about gRPC and how it impacts your daily digital life. gRPC is like a universal translator that makes different computer programs work together instantly and efficiently. This is why modern apps feel so fast and responsive compared to older technology. Real-world benefits you experience include faster app responses, better battery life, more reliable connections, and smoother real-time features in everything from messaging to gaming to navigation. The Python examples show how accessible this technology is. You can build real applications with just a few lines of code that mirror the functionality of major commercial systems. The technology particularly shines in scenarios requiring real-time communication, like food delivery tracking, online gaming, video calls, and collaborative tools. While most people will never directly use gRPC, understanding it helps you appreciate the sophisticated engineering behind the simple, seamless digital experiences we now take for granted. As our world becomes more connected, smart homes, autonomous vehicles, AI assistants, technologies like gRPC will become even more crucial for creating the integrated, intelligent systems of the future. The next time your food delivery app updates you in real time, or your game responds instantly to your actions, remember the invisible communication magic happening behind the scenes. Thank you for your attention. Please subscribe if you haven't done so already.